Righto, I'm going to set up for this little worm shaft that we've got here. Diameter at the end is going to be a nominal 30mm. I've just taken a very light skim pass off this bit of black bar, knock the rust off and get it cleaned up. First thing I normally do when I'm starting a machining job like this is just do a check on if there's any taper. You know, if there's massive taper, we need to adjust the tailstock, but it's worthwhile just taking that skim pass off, get that rubbish off, and then take another skim pass and see where that's actually sitting. So we're going to do that now. It's noisy with that feed on. Let's see how that looks. So that's measuring up at, we're looking at there, 36.98. Now at this end of the show, 36.99, so 0.01 millimetre taper. So that's sort of down to about 0.3 of a thou. I'm not going to worry about that, that's pretty spot on. Right, we'll get to roughing this out. I'll just sort of mark out basically where my lengths are going to be. So 79 for that one. So we'll come up to about 77. Touch off. Alright, so we'll rough out the smaller diameter, which is where our bearing braces are going to sit on. It's going to come down to 25mm. So as I see, we're about sorry, we're at 37, 36.9, so 37. So we've got about 6mm to come off the radius on this. Check that before we go any further. And let's bang on 26. This one's got to be back to 30, we're about 37, I'll call it. So we've got 3.5mm. We've got 3.5mm. pretty hot. We might let that cool down before we start doing our finishing operations. Let's see how we go. I take fairly heavy cuts on this little lathe. I once, many years in a previous lifetime, worked in a big heavy machine shop, and we had a big Mazak and a big Maxon lathe, and you know, we'd be putting bar stock in with, you know, 12 inches in diameter, 15 inches in diameter, and while we were roughing out, the foreman had come around. We all had amp gauges on our machines, and if it wasn't sitting up near the red line while we were roughing out, we were wasting our time, and he got rather terse at us if we weren't hammering up close to the red line on our roughing out operations. But yeah, these little lathes, they do struggle with the heavier cuts. So, all right, as I said, we'll let that cool out, and we'll come back and do some final measurements and some final finishing. Right, so we've got exactly just shy of 1 millimetre to come off this diameter here. On my drawing, I've put this as a clearance fit for the cone. What I'm going to do is make it an interference fit up where it seats at the end here. So this cone will be an interference fit. The other cone, you want to have that so you can actually very lightly slide that to set up your end floats. So it'll just have a very fine step just before it gets to this. So we'll set that up now. We'll just start taking that out. Check that. We should have about 0.1 left to come off once that is done. And what have we got? Yeah, hang on, 0.1. So we'll cut it down to that, and then we'll do a final machine. Set that up. Yeah, there's no tape on that at all. No tape on that whatsoever. So we'll have about a 0.02 interference in that. 0.03. I'll allow just a little bit to lineage. Check it and go down. 0.05. I might just come a tad more. Right, and do us. So if we're on the money. About 0.04. We'll lineage that last few micron off. What do we have down here? At the same 0.04 as well. We'll leave that where it is. As I said, we'll just lineage that last few micron off. This one here, as I said, we want to come down just slightly undersize so that we can set our end float on that taper roller or our preloads. size for size there. Being slightly undersized here as well means that you don't have to punch that cone all the way down. I don't know, hopefully that's about 0.015 under. So we're going to leave it at that. We'll just see how that's going to fit. It's going to sit about there. But we won't be able to push it. It gets tight there, which is what we want. Maybe just a fraction a bit too loose there, but it's not going to hurt us for this application. Once that preload goes on that, that'll be fine. Right, we'll get set up to machine our other steps in this. So we've got a bit of a step down, we've got our thread that we need to cut as well. We'll just machine this OD size now. It's 0.08 to go, so we'll finish it off with all that. Right. 0.08. 104 to go. Bang on the money, we'll give that a little inch. It's only for a seal register. We'll give that a little inch before we take that off. Alright, let's do these other diameters that we need to do, or this other diameter. Alright, so I'm going to just machine this register for the rear seal. And we've got about 3mm to take off the diameter on that left, so. Check it. For a left-hand pair of calipers would be good. Alright, we're about 0.2 up on size. Right. Right, 0.15 left to go. Go 0.6, I'll finish that same as this one here because it's a seal run. Go 0.06. Just so it's nice and smooth for the seal lip. let's adjust this tool. Do the run out for the thread next. There, I reckon. This doesn't have to be absolutely spot on, but we'll get it as close as we can. Zero it out at that. Right. I'll just slow this down a little bit. Just double check it. Right. Go and check what depth we need to bring that down to for our run out. Oh, if I can put that on my drawing, which I would normally do as a little separate blow up, so we'll come back and have a look at that. Right, so 1.5mm pitch is 0.92 deep, according to my Zeus. So we'll go 1mm deep on that. It gives us a little bit to play with. So. Right, so there's our thread run out done. Right, we might set up now. We'll cut that thread. It's a 1.5mm pitch for an M25 lock nut. So I'll get the threading tools set up and we'll get that one on the go. Right, we're going to get ready to cut this 1.5mm pitch. I've just done a scratch pass on this, and we're definitely at 1.5mm pitch. I've just set up the squareness of the tool just using one of the little swallowtail gauges. So I've got that set up. I've already done a scratch pass, as I said. I must admit, I've never ever used these insert style thread cutters, so this will be a first for me. I always grind up my own in high speed steel and set them up in a holder, so I bought these. They were dirt cheap. As I said, one of the Chinese supermarkets, I think. So we'll see how it goes. I don't tend to use the top slide in at the 30-degree angle. I set my tool just slightly below center, and then I like to side cut as I'm going down. So it's been a while since I've cut a thread, so we'll just see how we go with that anyway. Right, I usually cut fairly heavily for the first couple of passes. 22. Come you on it. That's good. I might just give that a spring pass to tidy it up and get it off. Excuse my arm on the way. Alright. Just give it a couple of little spring passes just to finish that out. I reckon that'll be on the money now. There it goes. Right, I'll just take it out of the, disengage the half nuts. I'll just give that thread a bit of a tidy up. Part that off. Now I've got to do a bore up inside here, but I'll part this off first so we can get that up inside the jaw, and we'll bore that out. We're going to do an M12 tap up at this end here, so we can flip that around, face, and then draw and tap that out. But yeah, so far so good. I might as well bring you back to set of parting off of this. Something all dread, I think. Just going to get my other container, almost out of oil on that one. I know. Right, we won't push it. I'll take the rest off with a hacksaw. I'll turn it over and part it out. Face it off. Righto, we'll just face it off now. I know what you're all thinking. No guts, no glory. Chicken out at the end to hacksaw it off. Oh well. I've been there so many times where parting has absolutely ruined a job and it hasn't come off right. So I'm a bit shy. Alright. I'm just going to take that out, measure what that length is, and then take it back to 111 millimeters. Alright, we'll set up and drill and tap that out M12. Alright, let's see how we go with this camera mounted over. Oh gosh, if I don't keep knocking it. Righto. Now, as you recall, we machined this diameter down so that this bearing is a sliding fit. My preference would have been just a very light push fit, but I reckon another quarter of a thou on that, quarter or half a thou would have been a lot happier. And as we talked about, we've increased the diameter here very slightly, so that we'll need to warm this up just to drop that over. Now it's important that when we fit these into place and we set the preload, that the drive is going through, for the preload, is going through the bearing ring into the shaft. And if it's too loose a fit on there, it's just there is a chance where that might rub. So we've got these other wonderful products, and that's just a medium strength bearing mount. But I like to use the nut lock, the 243, the blue compound, and I popped this on last night, and I can't physically get that off, so I'm going to have to tap it off. And the good thing with the 243 is that 9 times out of 10 you don't need to apply heat. These ones here, good chance you need to apply heat to get that off. A good sharp crack on the end of this should break that free. So just going to go over to the mandrel over there. I'm just going to set this up with a pin punch, and we're just going to give that a crack and see if we can break that free. But for my money, just the ordinary nut lock does the job that I need on these small components. As I said, the next job we're going to do after that is we're going to bore this out to 15mm and just do a little bit of a mod on one of these socket headed cap screws that we're going to use to then Loctite that into place for a drive with an Allen key. So that, as I mentioned, we can do the elements up on the on this crank disc. All right, I'm just going to go over and give this a crack and see if we can't get this this off fairly easily. Right, just got a pipe nipple, slip that over. We'll just see how easily this is going to crack off for us. Right, it's starting to move down there quite easily. I know. So you can see if you give that a good clout on the end there, just that breaks through. If you go for anything stronger than that 243 nut lock, you are going to have to put some heat on. The fact that we're going to be Loctiting that socket-headed head into here, we heat this up, we're going to drop that out too if we need to replace this. So I'll give that a clean up, and we'll get set up for the cutting of the keyway. No, we'll do the boring here first. We'll do that diameter 15 first, and we'll cut our keyway in. All right.